In this video, we are going to be looking at a block on an inclined plane. So by an inclined plane, we mean that you have such a plane that it is inclined at an angle of theta, and there's a block of mass m on that plane, and it is perhaps falling down. So we consider the various forces on this block. First of all, there's of course the force due to gravity. Okay, mg, or let us write this here, mg, right? Then there's the normal force, which is perpendicular to the direction of the surface of the plane. Let's call it n for normal force. There's the force due to friction, which is backward, which we will label small f. Okay, so these are the forces on the block. So having done this, let us now try to analyze the forces. What we will do is we will define the x-axis as being along the direction of the plane, and we will define the y-axis as being perpendicular to it. So n, the normal force, is in the positive y direction, whereas the friction force is in the negative x direction, whereas the force due to gravity, mg, is downward. So we must decompose it into x and y components. So let us draw something like this. This is at a right angle. Of course, this is right angle as well. So if this is theta, we can see that this is 90 minus theta, right? So you should be able to see that this would be 90 minus theta as well, and hence this would be 90 minus theta as well. So this angle over here is also theta. So what this tells us is that this force, that the force due to gravity in the x direction is, which is this, is mg sine theta, and in the y direction you have mg cos theta, right? So the force ma, so I'm denoting a as x double dot for the x direction, is mg sine theta, right? Because it's opposite to this angle, mg sine theta, minus the friction force, minus f. As for y, you have my double dot is normal force upward minus mg cos theta downward. So let's just take the y equation. So since the block is on the plane and it's not really going inside, uh, causing a dent, or nor is it flying in the air, y double dot has to be necessarily 0, right? So we get the result that the normal force is mg cos theta. And remember that the friction force is simply the coefficient of friction mu times n. So the frictional force is mu mg cos theta. We can plug this into the equation for x, and let's do it here. M x double dot equals to, let's do it like this. So from here, mg sine theta minus the friction force, we calculated it as mu mg cos theta. Okay, now having gotten this, what we note first is that m is common, So we can write the acceleration and the x direction as g. G is common here, so g sine theta minus mu cos theta. If we consider the block to be stationary in the beginning of its motion, then we can integrate this to get x dot equals to g sine theta minus mu cos theta, all of this being constant in time, and we get t. So x dot 0, which is the initial speed, is we considering it to be 0 since it is stationary in the beginning. And let's just call the initial position of the block to be 0. Then we can integrate further. So all of the constant in time stuff comes here. T becomes t square divided by 2. And yeah, so there you have it. You can calculate the position at any given time using this equation.